Hi. Thank you for staying through to the end of O'Reilly AI. Hope you guys still have some energy. I'll jump up and down. You want to all do jumping jacks or something? Yeah, it's been kind of a long week. I'll talk really fast, attempt to make this fairly interesting, and we'll do it choose your own adventure. You tell me if it's good. All right, so this is me. I guess I am introducing myself. I did make microchips before I started a second startup to do software, which was a bad idea. But because why do a second startup? But did a bunch of stuff. Started when I was 14, working on backprop in David Rumelhart's lab at Stanford. Learned how to program in C that way. Added momentum terms. That was fun. Built these chips. These are the first tensor processing units back in 2007. I think it was like 5 or 6 years before Google thought of making one. It came with, you can find on GitHub, Dimple, which was the first open source machine learning framework that was really at industrial scale. You could design models, compile onto the chips, got acquired by Analog Devices. Now it's in cars, and if you make a cell phone call, it goes through one of my chips, and it's in the iPhone and stuff like that. So, but the software turned out to be some of the most interesting part of the chip, so decided to go start a startup based on the software. So that's me. Before I go on and tell you about what we're doing in the Moore's Law of AI, maybe, I'd like to meet you guys so I can give you a good talk. So are you from an academic or university situation? No? Nobody? Are you a marketing professional? Oh, cool. I like marketing professionals. How about customer experience professional? Yes, excellent. How about an AI innovation professional? Lots of you, right. How about an IT professional? Gotcha, cool, all right. This talk is for exactly you guys, that's perfect. Can I do we're data scientists, can we do one more data project? I'm gonna ask you this survey. To do surveys correctly, you have to ask them in randomized order. So here's the order. I'm gonna ask you if you're using natural language or AI to process language from your customers in your company. So could be text surveys or chats or call transcripts or anything. So let's go through it. Who isn't sure if your company's using that or doing that? You all know. You deployed it, but it wants improvement. All right. You tried it, didn't work, so you didn't deploy it. Nobody. You deployed it, it's great. Yay! Wow, there's always one. But there was one yesterday, but that's it. Haven't tried it yet. All right. Yep. That's standard. All right, so again, this talk is for you. We have AI that turns customer natural language into impactful action and repeat customers everywhere immediately. Wait, I thought this talk was about Moore's Law. So I'm a practical man. I think we are on the edge of discovering a new scaling law for AI. But I'm going to show you in a really matter-of-fact way, and I'll hopefully deliver some value to you along the way. Started this company, and everybody talks about the customer journey. That's boring, right? Customers social and email, and they hear about your products, and then they learn about them and educate themselves online. Maybe they want to try it out. Maybe there's an unboxing experience. Maybe an AI assistant could be part of that. We're starting to see that. Maybe they get some customer support over chat, over call. Maybe they leave some feedback, do a survey. That whole time, your company's in the middle, and people are just kind of rotating around you. You all know this story. It's old news, right? But what's really happening at each one of those steps in the buyer cycle is people basically want to talk to your company. The real interface to the enterprise is natural language. And so what we really want to do is for every touch point, kind of bring them into contact with us and have a conversation. And we just don't have enough good people to do that. So we need AI to leverage ourselves so we can actually have these large-scale conversations with large groups of people. It doesn't have to be the enterprise. It could be a not-for-profit. It could be part of how government becomes better. It could be a lot of different things. But the vision here is that a small group of people or even one person could have an AI that allows them to have a simultaneous conversation with millions of people at the same time. Really kind of neat thing. So what are some of the stuff you see? So we get a lot of stuff like this. This was someone complaining to one of the largest health insurance companies in the country. This came in over a website. It's kind of long form. It's a little story, kind of almost a little short story. They're heartbreaking, some of them. They're like little stories. this is one of the largest financial services companies, and they've been getting a lot over their chat app and even over AI assistants. They've been getting a lot of short form input. A lot of people send us chat transcripts, call transcripts. So these are all different touch points in the customer journey, and they're all different forms of language, and people want to use machine learning to kind of analyze it all. But they're really different. Like a dialogue is different than a short form thing, is different than a whole little short story paragraph. And it's really hard to build one machine learning hub system to understand all this stuff. And that's what we do. And you can log in. So I just wanted to show you this is real and tangible. And once you log in, you can upload a batch of messages from your customers, like just a file like that, and just upload it. Or if you have time, before you leave, you can come to the Gamalon booth. And what you can do is you can fill out a little survey. And we'll give you back a personalized response. So you can take batch input from your customers, but we can take one-on-one customers. So we've actually found some really interesting things about how to make O'Reilly better through this. But I'm just going to say I like Ben Vigoda's talk. And I liked the snacks, too. I do need more. I'm tired. I want more coffee. All right. And I'm fearful of the future of AI because there's a Moore's law, and I want to be honest with you about that with quiet solicitude, I guess. I am Ben Vigoda. So if you do this on one of our iPads, you can join many, many customers who now are filling in free text surveys these days as the end of a chat or at a car dealership or wherever. What do you like about your car? What don't you like about your car? Really hard to analyze that stuff, really hard to figure out what's in there. But the alternative is to ask 500 questions. Do you like your muffler or don't like your muffler? Too loud? Is backup camera occluded? Does it have poor visibility? Really hard to design those. So if you really want to know what your customers are saying, you got to ask them and let them tell you. So anyway, so that's winging its way through our AI right now, being processed. So maybe the appropriate thing to do would be to tell you a little bit about our AI while it processes. So once we get all this language in, by the way, this is where the fun part of the talk starts. So once we get all this language in, we do something really different. So most AI, you walk down and they categorize it. It's like filing your email. So you take a natural language message from a customer, put it in a bucket, or even an image, cat, dog, ostrich. So you put it in a bucket, you file it. It's like hiring a temp worker to file stuff. What we do is different. We actually extract individual ideas and compositions of individual ideas and compositions of ideas from the customer messages automatically. So you can see here there's some urgency, surprise, confusion. This is a debit account issue. A debit kind of thing, there's checking accounts and there's credit card accounts. So there's different kinds of accounts. This is a composite idea. There's also other kinds of debit things. There's debit cards. And they think they've got an incorrect balance, right? So we can let that department know at least a little bit. And if this was longer, we could pull out more ideas. And so once we pull out the ideas, what can we do? Well, one thing we can do is we can give you basically a structured output. So we can say, here's all the customer messages, here's all the ideas that are possible that we found, and we put an X if the idea occurred in that message. So, and then we could put another column did they buy stuff from you? And then you could say is there any correlation between the ideas that people have, no matter how they set them, and what they did? So you could go do data science once you've taken your natural language and pulled the ideas out, or we could do it for you. So here what we're saying is the system is finding those kinds of correlations, and then it is basically saying, hey, we noticed one idea that's trending is there's some new account interest. There's an unusually large number of people asking questions about aspect of accounts and procedural requirements. And you could say, yeah, OK, that's an idea that I want to see how it's trending, because it seems to be correlated with a certain kind of issue, and add that to my dashboard. And so then we can automatically build a little personalized dashboard for you in your enterprise where you can track the trending ideas that are happening with your customers and how they're correlating or predicting with whatever else is going on in your buyer behavior. And so we've already got folks really using this. So like I said, one of the largest automakers in the world, and we did find out that their new backup camera gets water on it because the eyebrow was kind of designed wrong, and we were able to help them iterate on that in days instead of months and put it in the current model year, the correction. So they're having trouble with some of the seat comfort stuff they just had no idea about. So we found these unknown unknowns. Avaya, which is one of the largest telecom manufacturers, they make phones and switches and stuff, and through retailers, they sell this equipment all over the world, and we were able to figure out tons of stuff about sales best practices and what their customers are buying and how much and why. And one of the largest health insurance companies in the world that is working with us and was able to renew one of their top 10 customers because they were able to take, basically 60,000 health insurance employee members, and from all their input over the year, find out what did they like about their health benefits and what they didn't like. And when they went to the human resources, head of human resources at their client, they renewed this huge 60,000 employee company because they were able to say, we're going to fix these 3 things and we're going to enhance these other 3 things to make them even better. So it's really cool once you can pull ideas out of your customer language, what you can do with it. And so you can also, though, not just get those insights and make a corporate response, you can actually make a one-to-one response. So here is a little poem being printed out based on, at our booth, some feedback from O'Reilly that somebody gave. So more on that later. So all right, so who here would like to hear a little bit about actually some machine learning and how this stuff actually works? Because it's really pretty unique. Cool. All right, I'm going to go fast, and you can ask questions at the end. And some of this will become more clear as I go through, because I'm going to do a little cooking show for you. So, but at a high level, first of all, neural networks are kind of old news now. We're moving from fixed arrays of neurons and edges, synapses, to actually programs that can reconfigure themselves on the fly. Jan LeCun, who's one of the great heroes of deep learning, has actually started talking about this now. We call it differentiable programming. Some people call it probabilistic programming. Those are deeply related. But it's basically saying we got to move from fixed arrays to arrays that can self-configure. He's saying that now, which is heartening. But we started a large, really the largest AI program funded by the US federal government about 5 years ago. For the last 4 years, my company has been the largest performer in that program, and we've been commercializing this technology for the last 5 years. The other key is we think every variable in a machine learning model should know if it's wrong or not. Like, how certain is it? And there's some reasons for that. This is also an idea that's come of age. Some of my friends and colleagues, including my co-founder, started adding probabilities to TensorFlow. In fact, there's a talk going on literally right now in a different room about adding probabilities to TensorFlow by a friend of mine. But this is a really bad retrofit. It's slow. It doesn't really work. TensorFlow doesn't have a dynamic flow graph. There's all kinds of problems with this. So you really have to build from the ground up if you want to get that right. And then a couple things that we do that nobody else does. So first of all, machine learning models need to be composable. So if you train up a little model on a simple set of data, so it now knows how to, I don't know, recognize whiskers of cats, and you train up another little model that can recognize paws, then you ought to be able to put them together to make a thing that can recognize whiskers and paws. And if you put enough things together like that, you ought to be able to put something together that can recognize cats. Not just end-to-end recognize cats, compose things together to recognize cats. That's really a deep thing that we're going to need, I think. And then there's a fourth thing, which is, okay, what are those modules? Well, I call them ideas, because a person could tell one to another person, a person could tell one to a computer could tell one to a person, computer could tell one to another computer. So they're kind of these little objects inside the model that you should be able to move around and organize and like that. I'm going to show you UI to do that. And it's kind of like interacting with the hidden layers inside of a machine learning system. And I think that kind of auditability, that kind of editability is going to be really, explainability is going to be fundamental in the future. So let me show you like a practical example of this. So this was a fun little hackathon. We did a one-day hackathon we did at our company. If you get a Microsoft Surface or an Adobe app, you can draw a triangle. It'll put a little isosceles triangle kind of a particular size that it always uses, right, kind of in the vicinity of the triangle that you drew. This thing, I'll just play it again. I'm a terrible drawer. It replaces what I drew with what I meant to draw, which is so fun. Isn't that the promise of AI, that it will do what you wanted it intended to do rather than what you did do? Like, they'll anticipate your intention, the idea behind your act. And so it really is all about the AI going from your output, like your speech or your drawing, back to your idea or your intention. If it can guess your idea or your intention, you're cooking with gas. So let me show you how you do that. So here is literally the program we wrote to implement this thing. So this is a cooking show. This is a little cooking recipe for how to bake a triangle. So we're going to generate, instead of cakes, we're going to generate triangles. So how do you make triangles? Well, we don't know where the triangle is going to be. But we do know that the triangle is going to have a first corner somewhere. Let's put that down randomly. Second corner somewhere. That's random. But then we're going to deterministically draw a straight line. So already we're ahead of the game, because if we had a deep learning system, we'd have to show it a bunch of straight lines until it learned that like a straight line was like a thing. And maybe it would still allow for wobbly lines. Here, we're like, no, straight line. That's the intention. And then we're going to pick the third corner and draw another straight line. And finally, we'll connect the last two dots deterministically and draw a last line. So we baked a triangle. We generated a triangle. It's called generative model. Now, if we compare what it generated against some triangle that I drew all wobbly, then we can, they're a little different. But if we run this program over and over again, and we make a bunch of random choices over and over again, the triangle that it generates could get closer and closer if we adjust those blue choices until it matches the data, the thing I drew. So this is really, really powerful way. This is actually the right way to think about all of machine learning communication systems. This is how Shannon thought about communications. We have a model of the transmitter, of where the data came from, and we adjust the random variables in that model until we fit what we actually received. That is the right way to think about machine learning. So this is my friend Dan. He was the drummer in my band. He went from this to this after MIT, so he deserved an art project. So I don't have a video of a triangle fitting, but I can do something better. So this is, instead of 3 corners, this is 200 corners. And this is a single Bezier curve that goes through all the 200 points. And it's 50% transparent, so when it doubles back over itself, it's darker. And so every time we make a move, pick up, you can think of it as a hairball glued to a sheet of paper. Every time we pick it up and make a move, we see if that move brings it closer to Dan or not. And eventually it comes to look like Dan. So that's how we fit a generative model to data. Now, we don't actually do it over and over again, because that would be crazy. So we actually run the program backward, and it's really complicated, and that's our IP. But that's the basic idea. This is how modular, probabilistic programming, the next generation of deep learning is really going to work. It does work. So problem is, I keep doing this. The problem is, you don't want to write a triangle program and a square program and an octagon program and a chair program and a lamp program and a car program. That's too many probabilistic programs to write. So we need the computers to write these programs. So let's do something simpler. Let's have it write the programs. What we're going to do is start with a straight line program. So this is an even simpler program. One end is, it just has 2 ends, randomly chosen, and a line straight between them. It's even simpler than the triangle program. And so if we draw a bunch of lines, it will use that little line program, and it'll find the lines. And then if we then draw a rectangle, it will write its own program. So it'll write a program just like that triangle program, except it'll incorporate 4 line programs into it. And we'll call that program a rectangle program. And every time we draw a rectangle, it'll say, hey, I found a rectangle, which is made of 4 lines. And each of those lines have corners, and it knows that. And then I can teach it a post. And what I'm doing is teaching it some elemental ideas that can make other things out of. So then I could draw a lamp. And it will automatically, because it added to its library the rectangle program and the post program, it'll automatically learn that see that there's a rectangle there and a post. And if I tell it write another program, it'll learn that a lamp can be 2 rectangles with a post in between, and the post might vary in height. So then if I start drawing lamps of different heights, it'll say that's a lamp. And it's made of a post and a 2 rectangle top and the bottom. And the rectangles are made of lines. This is the only system in the world that knows that a cat is made of whiskers, and the whiskers are made of molecules, and it knows the parts and parts of parts of parts. That's how you get to complexity. So If I draw stuff that isn't lamps, like, I don't know, a cat scratch post or a tomahawk or something, it'll say these aren't lamps. I see the rectangle, I see the post, but these are not lamps. They don't cohere as lamps. They don't vary the way the lamp did. And we can just keep building up understanding until it can recognize lamps and chairs and things in any combination, any location, different sizes, that's fine. We taught a different kind of chair. It was pretty quick to do. And you draw a bunch of different stuff. That doesn't look like clutter to it. That looks like a bunch of different objects that are all in the scene. So that's the basic idea. Now let's do that with natural language. Oh, by the way, I should say, that was one person teaching it, not thousands. That was a handful of objects we drew, not tens of thousands of examples. It was running on a single core of a MacBook Pro, and it was in real time. So this is like insanely, like 6 orders of magnitude faster in training deep learning. Because you can reuse the ideas over and over again. You can stack them up. So you instead of having 1,000 images of cats, you have like 2 whiskers, 3 paws, 4 tails, done. And like 2 cats to show how they're composed. Compositionality of ideas is really a big deal. It's really a big deal. So we got a technology stack. I sort of make an analogy to TensorFlow. We call it particle. I'm not going to go into that. Here's a tree of ideas, but these are language ideas made of words instead of image ideas made of lines and points. So we said my ATM card, my code is not working for it, so we put in a customer message. It found the main category, it's a debit card issue, subcategory, it's a PIN number, and a specific issue that you need a new PIN. And it pulls those ideas out, compositional set of ideas, just like finding the rectangles and the posts and the lamp, and then it outputs that in structured form and in JSON. So now you know all the ideas that were present in this message and the ideas of ideas and the ideas of ideas of ideas. And it's robust to synonyms and grammatical variations and abbreviations. ATM's an abbreviation, and we said code instead of PIN number, and it's kind of weird. My ATM card, my code is not working for it. That's weird grammar, no problem. And so you could build one of these trees. You provide a scaffolding by telling the system, hey, I want to build out a little tree of ideas manually in the GUI. You just say, hey, I want to have a hotel action, a restaurant action, and I'm going to have a flight action at the bottom. And the things I can do to a hotel are I can like book a hotel, change my reservation, or cancel it. I can copy that little subtree over 3 times, and now I've got a little scaffolding for this system. Or what I could do is I could just give it a big bucket of 1 million messages from my customers. So I can say, I don't know, can I change my room to one with an ocean view at the 4 Seasons? I need to fly to Denver next week. Can we move my flight tomorrow to the evening? I want to book a table for 2 at Samovar in San Francisco. Dinner tonight was canceled. And it'll figure out the scaffolding of ideas. So it did the same thing we did for images. It just looked at all those sentences and figured out the recurrence of ideas and how they were connected. And it built the exact same hierarchy of ideas that we hand built. Now, if it doesn't come out with the exact same hierarchy, you can edit it if you want to. So you can cut and paste or cut and delete, whatever, you move stuff around. This is what it was thinking inside of its brain when it was reading all those messages. So that's how it came up with that tree. And so then whether you edited or whether it made it or whether you made the composition of ideas, once it has this model, you can say, book me a flight to Denver, and it pulls out the ideas. And it found the flight, and it said that this is a reservation. So it's that simple to build these models, and they're like this reusable workflow. And you can run it on lots of customer messages or any kind of text and find out ideas that were in there that you never knew existed. So it's just learning ideas from text and composing them into more and more complicated ideas. Like someday, hopefully we can run this on like all of Wikipedia. I think a Wikipedia would take like 107 years to read at a sentence every 10 seconds or something like that. I was looking at it. It says 270 gigabytes. So, imagine what this thing could learn from that. That would be, and like the level of hierarchy of ideas that it might be able to extract. And so the other thing it can do, here's how it learns synonyms. So once it has a little idea tree, we can say, hey, let me seed you with a couple words that represent each of these ideas. So log in or log on is one kind of idea. I'm trying to. And then what it'll do is it'll go through all the natural language and it'll find all the words that are used in a very similar context within the idea, as the idea tree is applied to the language. And it'll make some suggestions, and you can edit those suggestions. and then you can run it again. And in about 5 minutes of just teaching it, like, is this word the same as that word in this context? So it's just kind of playing around. It learns all the synonyms, contextual synonyms, but this is so much more powerful than like embedding word vectors or any kind of entity extraction because it's in context. These are synonyms only in the context of that set of ideas. And if you look at how long this takes to do, so if you think of development cost as hours of a person's time, the rate at which we can build, like, Amazon talks about skills for Alexa. Skills are basically like top-level ideas, categories. At 97% recall, we can, in $2,500, we can build to the effectively almost the same number of skills as it takes other techniques a long time to do. So let me just kind of summarize what I showed you. So each customer has a unique set of ideas about your company, your product, your services. And these ideas are linked to how your customer is going to talk and act and react to you. And what we're doing is, despite complexity and variation in language, we can pull out the ideas, the compositions of ideas, and the compositions and compositions of ideas automatically. And then what we can do is discover correlations across those ideas and across behaviors that your customers are doing, and predict what they're going to do based on what they say. We can also print out a one-to-one action to them. Earlier I was typing in, and we kind of submitted that little survey result to the system. And so it's now gotten back to me. What it's done is it took all the ideas out of what I liked and didn't like about O'Reilly, and it generated a custom poem for me related to just the ideas that I espoused. And we printed it out. You can go get one of your own at our booth if you want. It says, so I said, I like Ben Vigoda's talk, also the snacks, and I wish there was more coffee. And it says, redwoods, wine country, seashore and bay, some long afternoons, a bag of chips is manna. Lithium for my cell phone, coffee with cream for me. There are no flat earths in the AI universe, and there are more tales infinitely untold than told. I guess that was my talk. So and it says the ideas are coffee and snacks and speakers, and it's kind of fun. So you can go get one of those if you want. Let me leave you with a thought about a Moore's law for AI that has nothing to do with hardware. Oh, before we do that, I'm going to give you one survey. So in your enterprise, because I believe in listening to your customers, right? So let's do that. So I'm going to ask you, which kinds of natural language do you want to attack next from your customers? So here's what I'm going to show you. In a good survey, you show all the options, and then you ask people in a randomized order. So raise your hand if you want to do this to sales meeting notes. 2 people, 3 people. Raise your hand if you want to do this with survey responses. 6 is a bunch of people. Email, a lot of email. Facebook Messenger messages. 1. Chatbot monitoring? Oh, yeah. Website chat transcripts? Oh, yeah. Good. Customer service support chat call transcripts? Everybody. Okay. So here, let me leave you this. Thank you, by the way. Thank you. Your input will be noted. Let me leave you with one little thought for Moore's Law. So this is just something to noodle on the weekend. Since I did so much hard work and delivered value to you, I get to wax poetical for a second. What's going to happen to this line over the next few months? Is it going to go like this? Like all the other machine learning supervised methods? The more effort you put into training them, what you're basically doing is you try to teach it more, you're basically erasing what it already knows, because you're overwriting all the neurons. The ideas aren't modular and composable. They're just like all holographically stored in there. So if you add more training data, you erase the old stuff. You get this diminishing returns. Or is it going to go like that? As we build up more ideas, can it use those as a foundation and combine them to make more and more complex ones? And will it essentially get faster and faster at learning new things? We already have started transferring ideas we've learned from one client to another. I don't know, but we're going to find out in a little while. Thanks.
Thank you, Ben. We do have some time for some questions. If you'd like to ask a public question, please raise your hand. Ooh, man in pink over here. Hang on. Salmon, it's not pink.
So you just made an important point. So I was talking with an AI company just last week. You said that you took client data from one client, and now you can apply those learnings to another client. How do you deal with the data issue?
Great. So first of all, Gamalon never shares your data with anybody else. ever.
Never,
In fact, for
ever.
some clients, it's like an air-gapped cage. But if our system learned how to say please and thank you from your data, and we can go in and we can see the idea, it's fully GDPR compliant, auditable, you can say, oh, it's a please and thank you idea. Well, we've got two plans. You can go it alone, in which case you get a blank slate to build up ideas on. You gotta work with our system and do it. Or you can join the family plan, in which case we will share generic learning that is not specific to your industry vertical, but we see how, like please and thank you happens across every industry vertical, banking, insurance, automotive. It seems okay to share, it's not competitive. So if you join the family plan, you'll get the benefit of everybody else's please and thank you learning, and other people will get the benefit of yours. This is the first time there's going to be a marketplace of ideas, of machine learning ideas. Just like we sell books and articles, or at least we used to. This is like a book that you could run in a computer. Like this is a set of ideas that you can like hand to somebody else and they can like action them, right? And so there's gonna be a marketplace of that because now we've got a way to break up AI into modules, just like we can do with regular software, right? Like there's GitHub and there's all these software modules and you can mix and match them.
Any other questions? Yes, up here.
So this is more a hypothetical question. So after looking at your solution, so there is a proposal that I want to solve or try to solve in my companies that I've worked in the past, which is, I think customer support in general sucks in every organization. Customer support sucks in every organization. They have hierarchy of level 1, level 2, level 3 nonsense, and I hate it so much. So we want to kind of remove all that layer out. So there is a lot of documentation, PDF. Every product has huge amount of documentation. There's a lot of internal Wikipedia, FAQs, and everything.
Perfect, yeah.
So I want to kind of replace that entity with a chatbot. We'll talk to you and solve the problem in 2 minutes rather than going through 1 iterations and then level 2, level 4, and then solve it after 6, 7 days. So is that something that you have already solved it, or is it because that's what I want to solve?
Yeah, we've got a couple of those projects running right now, and one of the beautiful things, I love that. So the use case is, can we take all of our support documentation, and can we take all these questions that are coming in from customers, and can we match the documentation, the answer to the question? And you can run in this system, you can run the documentation through the same idea tree that you ran the messages through. So if you build up the idea tree, you can be like, and that's what we're doing with these poems. So if you think about the poem that comes back, each line of the poem was attached to one node in the tree. So when I say a bunch of things and a bunch of nodes in the tree light up, so those are the ideas that were in my message, when those nodes light up, what it does is it says, I'm gonna grab that line of poetry. We hired a beautiful poet in Boston to write these lines of poetry. We told them this idea, and we gave them the ideas, and they wrote a line of poetry inspired by that. So that's like your FAQ or your documentation. And so, if they ask about a specific set of things, they're gonna get back documentation that's specific to exactly the stuff they asked about in the order they asked about it in the hierarchy that they asked about it. Follow-up question.
One follow-up question allowed.
And I also want the context related to it, because depending on who is asking that question, the answer should be different too.
Exactly.
Okay.
So in that case, you can say, hey, I've got several different kinds of users, and you can put the same tree under 3 branches, one for each user, and you can attach different FAQ material for the 6-year-olds, the 90-year-olds, and the 40-year-olds. And so depending on, you'll have to have some other data or some way of knowing how old they were in that case in order to decide which tree to run them through, but you can totally do that. Wonderful, that sounds great.
Hello.
Hello.
I had a question about ambiguity. So,
Great question.
For things about customers asking specific things, it's not easy to get the idea, but we run into a lot of people saying, my card's not working. You're like,
Which
what kind
card?
of card? Is it or like PIN, which means 7 different things depending on what you have or even what you're looking for. So how does the model either correct for or like disambiguate for those
I'm
commands?
kicking myself for not literally having that exact demo in my backup slides, because I do have it. I'll show it to you after if you come up, because I don't want to try to look through slides while I'm up here. But yes, it will literally say, did you mean a credit card or a debit card? And if you don't specify and refuse to answer the follow-up question, if 60% of the people are debit card users and 40% are credit card users, like a rep, it will sort of assume the former, right? Because it's like you just get more of those. And because it builds up probabilities, it's a probability-based system, it knows those statistics. And so it'll default to, did you mean credit card? If that's 60%. And if you say no, then it'll go to the debit card. But it has the same kinds of, so it turns out humans, according to all the research that's coming now, are really probabilistic Bayesians. We're very close to it, except when we don't have enough time to think, or we're starved. That's thinking fast and slow. But if we think slow, we're Bayesians. And so a good rep would, if most of the complaints about cards are credit cards, and someone says, I've got a problem with my card, they'll say, was it your credit card? Right? And then the person can just confirm. Or they can say, no, it's a debit card, in which case we add that to the utterance, run it again, and now we know.
Time for one more question if you want. No? I'm sure Ben will take some private questions.
Absolutely.
If you'd like to
Yeah,
chat
I
with
can
him
stick
afterwards. Okay, thank you very much.
Thank you.
We are all Bayesian when we're slow thinking.
When we're slow thinking. All right, thank you very much. Talk to you soon.